So the very first thing from 3.1, and there'll only be one of these on your test, I told you I've already seen it, is you have to solve a system by graphing, and it won't be a really hard one. It'll be something like this. All right? So we're only going to do one of them at the test level. So in 3.1, I think you guys had a Delta Math assignment for it. When it says to solve by graphing, you're going to have line number 1, and you're going to have line number 2, and where they cross is your answer. I'm going to go to line number 2 first because this is in slope-intercept form, so it's really easy to graph. Where do I put my pen? That's the slope, so that's the answer to my next question. -3 on the y-axis. Yep, this is the mx plus b, and the b, or the y-intercept, where it hits this y-axis, is -3. From there, I'll use the 2 to slope it out. What do I mean by that?
Up 1 over 2.
Close.
Up 2 over 1.
Yep, you're close though. Up 2 over 1. So remember, it's rise over 1. We always run to the right, and I'll make a very neat graph. So I'm down at -3. And I'm going up 2 over 1, up 2 over 1. You can do it a bunch of times if you want, up 2 over 1, but once is generally enough. You make as neat a line as you can. Normally you'd use like, yeah, I don't know if that's the neatest line, but it's as good as it's going to get. All right, the red line. You have 2 options of how you want to graph it. You can use the intercepts or the zeros because they're really easy to find, Mason. If x is 0, what would the y have to be? 0 plus what is 3?
3.
Yes. So this one's set up really nice. We're just going 0, 3. And if y was 0, what does the x have to be? What plus 0 equals 3? 3, right? Or maybe you're like, but I like the slope-intercept thing. So suppose Parker says, I like having it solved for y. He would then go like this, right? He'd go over here, and it'll work out the same. He'd say y would equal, and he'd subtract that x, right? Then you'd say, well, it's got to be -x plus 3. And look, that would put you right here, down 1 over 1, down 1 over 1, down 1. You'd still end up heading right through here. When it asks you to solve it, Quinn, what are they looking for as an answer?
The points they meet.
Yes, the point of intersection. So you always have to write your answers as a point, 2, 1. That's solving by graphing. That was 3.1. Does that make sense, Jackson?
I didn't do that part. I only did the nuance.
So, and that was Delta Math for you guys, and you were literally just graphing the line, except the 2 book workers, but you guys had to graph them anyway, so it's really similar. It also said to do it by substitution. So over here, we're going to take the exact same ones, and we're going to get the 2-1 by substitution. And this was 3.2. This would have been your Friday's day. I'm not giving you 50 minutes of notes, like 3 on each section, just to keep it real. But here we go. I'm going to have the same 2 lines, the red one, which I'm not going to graph now, and the black one. So I'll give you a minute to rewrite them. So this would have been, you guys, most of you have Miss Peterson, you had a whole worksheet on this, I believe.
I think it was last night.
That was the next one. It's a yellow worksheet, yeah, it's coming. All right, it's the example on the bottom. When it says by substitution, you take whatever one says, whether it says x equals or y equals. This one says y equals, so I'm going to grab it.
Oh, you have to do this one?
And you put it into the other equation. So one of them will say either y equals or x equals, or it'll be really easy to solve for, and you're going to go like that. Does that make sense, Quinn? You're going to do a rewrite. You're going to say the x plus the y, which I'm substituting out, has to equal 3. And you're going to solve this, right? And when we do that, we have 3x's minus 3 is equal to 3. Go ahead and wrap this one up for me, Mason. Finish solving it.
You have to add 3.
add 3.
And then you divide, you have 3x equals 6, and you divide by 3, and you get
X equals
2.
2. Shouldn't be a surprise because it's the same set of lines. So the X is 2, both when we did it graphing and by substitution. What was that?
You have to plug it in.
Yes. And the question, those of you watching the video, is he said you have to plug it in. We do. And you can plug it into either one. I always like to plug it into the one where it's already solved for. So Betsy, what I like to do, since this says y equals, I might as well just go take this 2 and put it right there. Because it says y equals, and I'm looking for the y. But you actually could put it here and have the same answer. So 2 times 2 minus 3, which is 1, which makes sense. We knew it had to be because we already did it by graphing. Or if Betsy's like, no, I don't want to put it there, she'd go what plus 2 equals 3. And she'd still get, oops, sorry, the X should have gone over here. She'd still get the 1. Same answer both ways. So kids always say, well, why would I do it this way if I can just graph it? Because a lot of times they don't work out so nice. And even if your line's a little off, then this is off. So the algebra is actually better because it would work if they intersected at 1.7, 3.9, where if Quinn graphed them, he would have probably guessed 2, 4. Do you see it? When you're graphing, there's room for error. When you're doing it with substitution, not much room for error. So now into yesterday's. All right, so that was 2 sections in 5 minutes. All right, the next one is by elimination. That means eliminate a variable. Best case scenario, this is actually from the bookwork, Betsy, so you'll be redoing this one. I don't remember what, I try to pick from worksheet, Delta Math bookwork. When Betsy does this one in section, it'll be her 3.2. I think you guys, it's 3.2b. She's going to try to eliminate a variable by adding them up. She doesn't have to mess with anything. What variable will cancel off if you add these equations up? The y's will. So there's best case scenario, you can get rid of one or eliminate one and not have to fart around with it. Negative 19 plus 1 is negative 18, right? These always go to nice, easy algebra, negative 3. So my answer is negative 3, comma. Now, how do I figure out what the y value is? Yes. You plug it back in. Now, you can pull it in here or here. I don't really care which one. I think I like this one better because it's a little less messy and has smaller numbers. But it doesn't really matter. But you have to pick one of them. Some people might like the bottom one because there aren't as many negatives. So let's suppose that's Betsy and she's like, I don't want to put it in there. That's a negative 19 if. This one over here is equal to 1. Well, then she's going to put her negative 3 right here. And she's going to do this. 5 times negative 3 plus 2 times y is equal to 1. She'll have a negative 15 plus 2y, right, equals 1. And then go ahead and wrap it up for me, Mason.
You get plus 15.
Yep.
You get 6, and then you divide by 2, and you get 8.
And you get 8. He's a fast solver. That's why I keep saying that. Now, let's suppose that Tanner, you're like, I'm going to always put it in the top equation because I like it. All right? Don't write this down. Tanner would go up here and he'd say, nah, Betsy, I know you didn't like the negative 19, but I kind of like just having the x and not have to multiply them by 5. Here's what he would do. He would take that negative 3. Just watch, don't write it down. He'd say minus 2y is equal to negative 19. And if I asked Mason to solve this one for me, he'd say add 3.
I did that one.
Right? And get negative 2y equals negative 16. And notice when you divide by negative 2, you still get the 8. So they were asking me yesterday, well, how do I know which one to put it in? And what do you think my answer was? It doesn't matter. Be nice to yourself is what I said. If there's obviously one that's nicer, like if you're debating between plugging it into x plus y equals 2 versus negative x plus 13y equals 27, well, for God's sake, pick that one, right? But some kids always just pick the top one. All right, so now you guys all take out the 4 view of Miss Peterson. are gonna take out your yellow 3.2, and we're gonna do one where they don't cancel off right away. All right, so somebody find their
I'm
yellow
going with 3.2.
3.2, and you will have book, and you will have book as well, but it'll work the same way. It should, I think it's yellow, it says 3.2, there's a whole bunch, and maybe it's pink.
3.2C, right? This is for the day.
Yeah, we can do 3.2C. It says by substitution or elimination. Oh, look, you have a whole bunch done, Mason. Let's pick. I'm going to actually go look at number 6. I guess it's pink for you
Well, I
guys.
have some circles that I didn't finish or need help with.
Number 6 is fine.
I'll go to look at number 6 and then number 8. I want to do number 6 because, oh, you circled 7. Let's go do 7 so that Mason's not sitting there. So those of you at home, this is Mrs. Peterson's worksheet 3.2C, where you were trying to decide whether you wanted to do substitution or elimination. If you have Michener, you have the same thing on Delta Math. If you have Miss Cedarholm, same type of thing out of a book.
Wait, is
And
this?
actually, most of these worksheet problems are from the book, so odds are, if you have bookwork, you have this one somewhere. I just don't know what number it is. So this was Mason's, or all of you. This is, did I write it down right, Mason?
Yeah.
Just want to make sure I didn't make,
Yeah.
yes? All right, now unlike this one was so nice for me, and you guys are listening really well. You have been a lot better. So when, this was nice because I didn't have to mess with anything. That canceled right off the bat. But over on this side, I've got to multiply to get them to cancel. So if I had them up right now, I'd have a negative 3x and a negative 12y, and it's not going to cancel anything. So what you do is you need to figure out what you could multiply by to get something to cancel. It's kind of like 5th grade when they'd say, find a common denominator. Because you need to get the same number. So if those are on the bottom of a fraction in 5th grade, what would you have used for your common denominator? What do both of those go into nicely? 10.
10 and 40.
Yeah, and I'm not picking this one over here because, yeah, well, he's saying 40, I think, for the other side. But
Yeah.
I picked the one that's nicer, usually a smaller number, so I think I'm going to eliminate the x's. I'm going to try to create 10s. Does that make sense? So I would have to multiply this one by 5. And what would I have to multiply the bottom one by?
2.
2. Now I don't need to have a negative because they're already opposite signs, but watch, so don't you do this. Had it been like that, Quinn, I would have had to choose a negative 2 because they have to be one positive, one negative for them to cancel. But this one was good because when I wrote the problem down, assuming I wrote it right, that was already negative. Yesterday, the mistake they were making, they were doing great. One of the things though is they didn't multiply everything by 5. So you have to take your 5 and you have to multiply it by 2. You have to multiply the 8. And you have to multiply the 6, and that's what they're forgetting, is that other n. There's your new equation. For the bottom equation, you have to double all these numbers, Mason. So I think you wrote this down.
I have that, yeah, negative 10x minus negative 40.
40y. Oh, I get why you were goofed up. Like,
Yeah.
this is, you did it perfectly. You just didn't know how to answer the question.
Yeah, I know.
All right. So this one that Mason, I'm glad you did this so I don't have to do an example like this. By multiplying it through, notice what happens. I strategically chose it to eliminate the x's, but accidentally, what also happened is the y's are gone. So I end up getting 0 over here. They both were eliminated, right? So Mason, all you needed to do is keep going. 0 equals, and 30 minus 28 is 2. When that happens and you get 0, you just have to ask yourself, is this a true equation or a false equation? False. If you say false, you write no solutions. What that means, Jackson, is had we done it graphically, they would never have crossed. They would have been parallel. There's no solutions. Now, Mason, suppose you accidentally you tried to eliminate these, and then the y's were gone, and then over here, maybe if that had been a 30 and a negative 30, suppose you had that. Is that true or false? True.
True.
Then your answer is not just one solution, Not no solutions, but it means the lines were the exact same line in disguise. Because everything wiped out. It was itself. And so where do these guys cross? Everywhere. So I think that's where your teacher says try infinitely many. I don't know, I don't teach the class. Does that sound familiar? Infinitely many. But this one that you asked me, Mason, that was a 2. That's not true. There's no solutions. They never cross. All right. So I think I'm going to open it. I'll keep running the video, but those of you with the pink worksheet who started it, do you have any others you need to go over? Oh, you started it,
I
Tanner.
just had a question.
Yeah, I didn't do it myself.
You don't think so?
No, I know I didn't.
Okay, well, let's go take a look at your, no, this is right. You're just using substitution because it says either or.
Is it, yeah, I was
So
about to
you're
ask.
fine with that.
Is it not, you get the same answer from
You'd
all
get
of
the
them?
same answer. It's just some of them are set up but to do substitution
Yeah,
with
no,
them.
I know how to figure out now if they are like.
So let's do this. One more off of Mason's and Tanner's because they've started. So you guys go ahead and tell me what one you'd like me to do. Mason, give me one.
Well, I'm working on 5 right now.
All right, read it out.
Actually, 6 or 4. I had a question on.
All right, give me 4.
It's negative 6x
Yep,
plus 5y
yep,
equals 1.
yep.
And then over 6x plus 4y
6x plus 4y, what did that equal?
equal negative 10.
Negative 10. This one I don't need to mess with anything, and I definitely do elimination. I won't do substitution. These are gone right off the bat. So no need to mess with anything. You're just going to add these up. These are going to go, because negative 6 plus 6 is 0.
I think I got past all this part. I think I just got like a wrong answer or something.
Well, I get 9y when I add these up, and I get negative 9 when I add these up. And then I'll do what you told me to do on the last one. You said to divide by 9, right? And I get y is equal to negative 1. Make sure that goes in this slot. Now you have to go back up to either equation and put the negative 1 in for the y. So you just got to be a little careful. So I'm going to grab that negative 1 for the y, Mason. I'm just going to go to the top one. I'm going to put it right here. And you have to do a little rewrite on it. So I'm going to go to the top one and go negative 6x plus 5 times the negative 1 equals, there's a lot of work, but it's just,
I think I got it actually. No,
yeah, and then you just need to solve that. I think you'll end up getting x being 1 or negative 1.
Negative 6. Or no, negative 1. Yeah.
Negative 6x would equal 6.
It's not 6. I messed up.
Yeah, so I think it's negative 1, negative 1. But I see Tanner, or let me take a look at yours, Parker. You're starting at the beginning.
Yeah.
This first one is set up for substitution because it says y equals. So I just will put this in for the y. So we'll do your number 1 together, and then I'm going to stop the video. And again, we're on the pink worksheet for those of you who had the worksheet. Again, if you have Delta Math, you'll be doing the same thing. So Parker, I'm just going to steal, well, let's do yours. All right, so the number 1 on this worksheet, and it was their choice, whether they got to do substitution or elimination. I actually like elimination better, but this one's set up so nicely. For the only time I'd use substitution is when it actually says y equals. So what I would suggest you do, Parker, is you're going to grab what y equals, right? If it didn't say y equals, I'd immediately go to that other method. And I'd never choose to graph unless they tell me to. So whatever y equals, you need to go substitute it in. If it said 6x plus y equals negative 11, I won't bother with substitution. Okay? So when I go plug that in right there, I'll go negative 2x minus 3, parentheses. I'm going to put that y in right here. It's 6x minus 11 has to equal negative 7. So then, Parker, when you're solving this right here, right, what will I do first to solve it? Distribute. So he's going to go like that. Make sure you grab the negative with it. Now the negative 2x minus 18x. A negative times a negative is a positive. All right, I'll stick with you, Parker. And Tanner, I think you're doing this one, or do you chose to do this one with substitution anyway, didn't you? All right, so what would you do next on this one?
Me?
Whoever.
Combine like terms.
Combine like terms. Yeah, I take my -2 and drop it 18 for negative 20 x's. Yep, are you writing it down, Quinn? We're doing your number 1, right? I think you're writing it down. Perfect. Then to solve this for x, subtract. Yep. So they said, if you can't hear them in the video, they said get negative 40 and divide by negative 20. So be careful you don't quit, because remember from the graphing, your answers are points. These are actually where 2 lines cross. This would be at 2, comma. Now you got to head all the way back up. You have to plug that 2 in. And the easiest place to plug it in to get the y would be right here, because it actually says y is equal to 6 times x, which we said is 2, minus 11. 12 minus 11 is 1. So while they're continuing to work, those of you at home, distance learners, I'm going to show you graphically just on this one that I just did with Parker, what it looks like on the Desmos graph. So I'm going to go to the original. They saw me graph them last week, but it's always good to see what you're actually doing. So I'm going to go back up to this top one, y equals 6x minus 11. I'm going to type it in. I'm going to type the bottom one in. And we're going to see 2 lines. And if their algebra was right, they're going to cross right here. So y equals 6x minus 11. I'm going to head on to Desmos here. So I was doing this yesterday, and I still have y equals 6x minus 11. And Parker, can you tell me what the bottom equation was again? Because I forgot it. And this is number 1, right? 3y equals 7? Negative 7. All right, and notice there's my 2 lines. Had it said solved by graphing, I would have graphed them and said 2, comma 1. Does that make sense? And that's what we got using substitution. Had Betsy said, I don't like substitution, I'm going to do elimination, she'd get 2, comma 1. It's 3 ways to skin a cat. Okay? So you guys continue working. I'm going to stop this.